All right, hopefully this works. Okay, so what I want to do here is just answer questions. Before I answer questions, I mean, I already recorded a video. I'm assuming you watched the video, so I'm not going to do the same thing in the video. But I will tell you this. I prepared 4 exams, and everyone who has told me where their exam is going has the exam at that place. So there's a few people out there that still haven't told me where to send the exam because you didn't fill out the survey. So, what's that? Yeah, there's another survey. Yeah, there was one for the midterm and there's another one for the final. Yeah. Are you Timothy Lippett? Yeah, I got you, Kate, taken care of. Thank you. No problem. So we got you taken care of. So anyway, so we got you handled. You're fine. But yeah, there's a few students that hadn't turned it in, so please make sure you do that because I have no idea where you're taking it. I mean, I can assume you're taking the same place, but some people change locations. So I'm going to tell you, for the 4 exams that I made, they really follow this. They really do. In fact, 3 out of 4 have the friction problem, and every one of the 4 has the other 5 listed there. Every single stinking one. So this makes life easy. You know exactly what to study. Okay? Now, a couple of hints here. Moment of inertia. Okay, this should be a problem that you all clean up on. Okay, this should be easy. It's going to be a composite area, and the only thing you need to know with the moment of inertia is, let me pull it up. Okay, with moment of inertia, the only thing, let me pull up the sample final, because you know it's a good example of what it would look like. The only thing you need to know with moment of inertia is this equation right there. I plus I bar plus AD squared. That's it. You need to know how to use that, okay? And the key thing with that equation is to remember this, is that when you're writing, hold on, you're writing I equals I bar plus AD. What that's squared. What that's really saying is this. Let's say you have a shape like this. We all know where the center of a rectangle is. The center of a rectangle is something like that, right? And let's say you want the moment of inertia about some other axis like this. We'll call it the x prime axis, okay? What you do in order to get the moment of inertia about the x prime axis, which should be like this, we could call this Ix prime if you want to, all right? You get the moment of inertia about its own centroidal axis first. That's this. That's the centroidal axis. In this case, it's the 1/12 base times height cubed, and those formulas will be given to you, okay? Make sure you look at the sample test because the sample test shows you the formulas and everything you'll get. And then you have to add something because you're not getting the moment of inertia about x. You're getting the moment of inertia about x prime, which is going to be larger. So what do you got to do? You add in the area. Of course, we should know what the area is, right? The area of a rectangle. And then d is simply the distance here between the centroidal axis in green and the axis that you care about in purple there. That's it. All you have to do with the composite area is add up the pieces, and then that's it. Now, the only other tricks I can do besides that is sometimes you might have a negative area. If you have a hole, that's a negative area. That would be a circle. So you count it like it's a regular circle, okay? And then you subtract it. You don't add it, okay? Now, I'll tell you, looking over all the exams, the only things are going to be rectangles, circles, and triangles. That's it. Rectangles, circles, and triangles. So you should be able to do this. Rectangles, circles, and triangles. They're on your sheet. Okay? There might be some negative areas. It's a possibility. So you subtract them. Okay? So that's a problem you should clean up. Okay? That's a problem you should clean up. Now, let me take a look at some other ones. The next thing in fact, honestly, if I'm doing this exam, I'm going to that problem first. Getting it done, cleaning it up. I'm probably going to that first. Do you have to? I'm just saying my strategy in exam taking is to try to do the easy ones first. To me, that's the easiest problem on the exam. Okay. Now, what else is there? Probably, in my mind, the second easiest problem on the test would be a trust problem. In my mind, now, you could disagree with that, but every exam has a trust. Okay? Every exam is a trust problem. Okay? So that's like this. Right here. Okay? And so every exam has one like this. You have to decide whether you're going to use method of sections or method of joints. I have both lectures on either one. I will tell you honestly, I usually think in terms of method of sections first, because most times it seems to be quicker, okay, to do it that way. So for instance, in this sample exam, it says determine the forces in FE and FC. Well, FE and FC look like you can make a cut through them. I can't really draw on this thing, but what I could do is, let me do this real quick here. I could kind of sort of draw one here, right? Is you've got, let's see, here, 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 right? And then you got something across, and then you got this, you got this, right? That looks like it's right there, right? The key ones, if you look at the picture that you want, are FE and FC. Well, I'll label them here with a different color. Oops. No. It's, yeah, that one and that one. So it's right here and right here. Well, if you see two beams like that you want to do, the easiest thing to do is to make a cut like that. Always cut through the beams you're interested in solving for. You can't cut through more than 3. So what happens when you do that? Well, you're left over with this piece. It's going to look like this. And then this is connected here. Okay? Like this. Now you can't forget, are there any loads on there? Yeah, there's a load at C, 800 pounds. So you still have to put it on. You can't forget it. You can't forget about the 800-pound load. And you have to figure out what this load is here at D. You have to do that before you even do anything. You have to figure out what that FD is, right? And then what I recommend you do is you draw every one of these internal forces as a tension, like this. So they're always pulling, right? Like that. That's how I would do it. And it turns out you got FE, FC. So this is FE, FC. And this one is BC. All right? Now, this is super easy because if you want to sum the moments, if you want to figure out, for instance, FE up here, if you want to figure out this one, super, super easy. Sum the moments about this point C. Because if you sum the moments about C, boom, done really quick. So easy, right? So anyways, that's my recommendation, is go after that trust problem. And you know, here's the great thing about trust problems. They're really easy to study for. Just do some trust problems. That's it. Do like 3 or 4 trust problems in the back of the book. You know, they have answers in the back of the book. You can find answers. You'll get the hang of it. Boom, get those done. Okay? Those are the 2 easiest problems on the test, in my opinion. Okay? So, next thing I would do now is, let's see, probably the 2D equilibrium problem and the 3D equilibrium problem is where I go next. A 2D equilibrium problem should be something that's pretty easy for you to do. Okay? It's stuff that's really we were doing on the midterm. Okay? A 2D equilibrium problem, you know, an example like that on your sample test, like this. Okay? Everything's in 2 dimensions. Okay? You know, everything's in 2 dimensions. And you know, the key thing is recognize a pin here at C has a CX and a CY. And this AB even says it serves as a short link. Do you remember what a short link means? It means a force is in the direction of AB. Right? And then there's a weight here. It looks like it's 500 pounds. So if you were to draw a free body diagram I would draw a free body diagram of that gear, right? And I would draw it like this. I draw a gear. I would have a force like this, FAB. I would have a CX and a CY. And then over here, I've got 500 pounds. Okay, like that. How do you solve? I would sum the moments about C. Sum of the moments about C equals 0, right? That should enable you to solve for FAB. And then I would sum of the forces in the x direction and sum of the forces in the y direction equals 0 and solve for CX and CY. Now, how are you going to study for a 2D equilibrium problem? You're just going to try to do some more problems. And basically, when you identify that problem, you're basically the only things you're going to do is a moment equation and 2 force equations. That's it. This problem should be an easier problem on the test for you. Okay? That's it. And here's the thing. You might screw up in writing something out or whatever, but at least try to get the equations written down. At least try to get the things written down. That's the thing to remember for this test. Don't leave it blank. If you don't know what to do, some forces, some moments, do something, right? Write some equations out. If you get stuck, some forces, some moments. Write some things out. Free body diagrams as well, okay? I'll be looking for free body diagrams, especially on the 2D and 3D equilibrium problems. Okay, I'll be looking for that. So make sure you write them out. Write the equations. That's most of the test, folks. If you get stuck, if you get to a point and you're like, man, this is so messy, I don't know how to solve it, move on to something else. Okay, don't waste all your time trying to solve a problem for just a few points. Get the points elsewhere. Then at the end of the exam, come back to that problem and go, oh, I know how I need to do this. Okay, I need to be able to do this. Okay, maybe it'll refresh your mind of how to solve it. But in the end, most of the points are not going to be from solving it. Most of the points are going to be from free body diagrams and setting it up. Okay, that's how it's going to be. All right. So I'm going to do that. That'll be my strategy, and then the 3D equilibrium problem. Yeah. Okay. So that's going to be some forces x, y, z. Maybe some moments. Here, let me give you a hint. Okay. I can't make it super messy. I don't think I have any of them. I might be wrong on this, but I don't think I have a problem that has like 6 equations, 6 unknown. Like that's super messy like that. I don't think I do, because that's messy for you to solve. The ones I have, I think, are simpler and break down a little bit easier. Okay? I could be wrong on that, and I'm trying to remember all the problems, but I don't think they do. I think they're all pretty easy to solve. So you shouldn't get yourself messed up in lots of equations and unknowns. I don't want you to have to, like, because to ask you to solve 6 equations, 6 unknown on a test is pretty messy, right? You'd really have to use a matrix method, and that's not that hard, and really, honestly, it's not that hard, but I usually don't ask students to do that on final, okay? So even if it's 3D equilibrium, I don't think you'll see 6 equations, 6 unknown, okay? I don't think you'll see that. On this test, you certainly don't, because even though this is a 3D equilibrium problem, it breaks down pretty easily, okay? You've got here, it's a ball and socket at A, so it only has force reactions. Okay, it only has force reactions. You got to remember, a ball and socket only has force reactions. So you've got reactions at A of X, Y, and Z. So those are unknowns. And then you've got some kind of unknown in the tension in the at B there. But beyond that, that's it. And these forces are actually pretty simple on this one. So this one is not complicated to solve. It's a good practice for you to solve problem number 2 on your sample. It should break down and be easy to solve. You should not have like a big matrix where you have like tons of equations, tons of unknowns. It should break down to really easy, like, oh, that's easy, that's easy, that's easy. It should break down and easily solve, okay? And I know at least several of the examples I have in the tests I'm giving you it's not that hard. Like it breaks down pretty easily. It's not like I can think of them. There's nothing too crazy. Okay, so you shouldn't have something that's, oh my gosh, I got all these equations and all these unknowns. No. So and then frames and machines. That one's probably harder, just because you got to break it up into pieces. Okay, you had homework on that. I know some students had struggles with it. Okay, you've got to break it up into pieces. You've got to do that. So in this case, is a good practice. The only way you solve this problem here is to draw a free body diagram of that bucket, the bucket itself, that, or whatever this little thing is that holds the. Let me zoom in. You got to draw a free body diagram of that bucket AC. Okay? And then if you draw a free body diagram of that bucket AC, if you don't do it right, you get stuck. Here's why. You'll get stuck because if you don't recognize link AB as a two-force member, if you just put a pin at A and a pin at C, that's two unknowns at A and two unknowns at C. If you have AX and AY at A and CX and CY at C, you have four unknowns. You can't solve this, right? The trick to a lot of these problems have a trick. That's all it is a trick, is you've got to identify the two-force member. So, well, how do I see a two-force member? It's a piece, it's a member, it's a connecting rod, it's something that is only pinned at two places. It only has force at A and B. That two-force member AB only has force at A and B. Therefore, the force is in the direction of AB. Okay? That makes the free body diagram much simpler. It makes it look like this. See, if you draw it like this, I think there's a force here, right? 2,000 pounds. If you draw it like this, AX, AY, CX, CY, you're stuck. You're completely stuck. But, so don't do that. But, if you draw it like this, and you go, oh, this is really force AB like this, and I know the angle of that force. Here's CX, here's CY, and here's a 2,000 pound force. Oh, now I can do this. Now all I have to do is some moments about C. Boom, done. I can solve for FAB, solve for the other two. But if I don't see that, and I draw the free body diagram like I have on the left there, totally stuck. Now that's the thing. If you, when you see a frame and machine like this, and you have to break it up into pieces, it's okay to draw the free body diagram initially like that on the left. It's okay, but then you've got to realize and go, I can't solve this. At any point you see something, you're like, too many unknowns. I can't solve this. You can't have more than 3 unknowns in a 2D equilibrium problem. You can't have more than 3. You can do 3, but you can't have 4. So what you got to do is you got to go back and look at this and go, where's the trick? Where's the trick? In this problem, you say, where's the trick with AB? Oh, it's a two-force member, so I know the direction of the force. Okay? Honestly, that's the trick on a lot of them. Not every one of them, but that's a lot of them. Okay? The other trick sometimes happens is that sometimes you have to draw two bodies together. Like, instead of drawing them as separate bodies, you draw them together, and the piece that connects them is now an internal, not an external force. So you could do that too. Yeah. Yeah, that certainly helped, right? Yeah. Yeah. Yeah, you know the angle of that. Yeah, you'd be really in trouble if you didn't know that. Yeah. Yeah, certainly that helped. Yeah. But really, I'd say the way to look at it is identify AB as a two-force member. Not so much that the angle was given. Yeah, you had to have the angle, but that it's a two-force member. So you know the direction of the force at AB lines up with the link AB. That's key. That's key. So I would probably do that. And then honestly, I would probably do the friction problem last. The only reason I would do the friction problem last is that it's, to me, and not every test has a friction problem. Okay, I think there's at least one that doesn't. But I'd probably do it last only because sometimes it's hard for students to visualize it and then they get stuck on it. Okay? So I'd probably do it last so you got more time in theory to work on it. So you don't get stuck. That's my advice. And again, remember, most of the problems in friction, it has what we call pending motion. With pending motion, then you can say if the motion is pending or about to slip, something like that, right? Then you can say the friction force is equal to mu times n. But you cannot do that in general. You cannot in general say that the friction force is mu times n. You can only do that if it's about to slip, because we really call that the maximum friction force. The maximum possible friction force is mu times n. That's not always the actual. One more thing, a hint that I know I've saw on one of the tests at least, so I know I saw this at least, is what happens when you have two contact surfaces like this. You have this contacting a corner, or this contacting like some kind of circle or something like that. Like what happens if you have, because it's when you have two flat surfaces in contact, that's very simple. We understand that. But what if the shapes are different? How do you handle the friction force? Like what direction is the friction force? So for instance, in case A here, if there's friction between, let me make sure I'm clear, this piece and that, where's the friction force? How do you handle the friction force between the two? Well, it'd be something like this. It would be perpendicular to the straight part, okay? Same thing here, perpendicular to the straight part, okay? So if it's like a circle and a straight edge, it's perpendicular to the straight edge, okay? Sometimes students get confused by that because they see a corner and they don't know how to draw friction at a corner. Well, it's perpendicular to the other surface then, okay? If you have two curved surfaces together, then there would be like a line. It gets a little trickier then. If there's two curved surfaces, you have to have a line through the action point, and then it gets a little trickier. That's how cams work, by the way. That's like a cam. You have like a cam connection. But in statics, we don't do anything with cams. So we're not going to have anything tricky like that, okay? It'll be simple. There'll always be a straight edge to do a perpendicular, okay? That I do know one of the tests has something like that, so I wanted to mention that. Okay, I'm sure you got questions. Who's got questions for me? I think I covered everything. I really try to hone this down. Who's got questions? I want to hear any questions. Yes? Yeah, like the numbers. I was thinking about posting maybe the numerical answers at least, so you can check your work. I did post, by the way, separate problems with solutions, but I haven't posted the numerical answers to the sample. I think what I'm going to do, I'll do this like tomorrow or Saturday. I'll post numerical. Give me at least a few days. I'll post the numerical answers to the sample test. So at least you can check your work, see if you're right. So I can do that. Because I really hope you work on the sample test. Yeah.
Can you explain this a little better? Just this is the only thing that I haven't looked at. You said the perpendicular.
Yeah. So when we have a friction force.
Can you put like an applied load in it somewhere so I can
Okay, let me see here. So let's say, for instance, let me try to come up with an example here. Let me see here. How about I have, I'm trying to come up with an example that's not the same as exactly the same as the test. Like, I don't want to just draw the whole thing. So I'm trying to come up with something, I mean, like when we have something like, you know, we had this example of like, okay, we're going to push a refrigerator, right? And I know this is not the same, but so we push the refrigerator and we know, oh yeah, this is easy. that this is the normal force and this is the friction force, because obviously if I'm pushing the refrigerator across, the friction force is going to be clearly it's going to be clearly oh yeah, hold on a second. Yeah, you know what? I was drawing the normal force. That's probably why I can use it. I'm drawing the normal forces here. I'm not drawing the friction. What am I doing? I'm sorry. You're right. Let me go back here, because honestly, the friction forces are here. I'm sorry. The friction forces are perpendicular to the normal force. I'm sorry.
Yes.
You're right. Now I'm getting everybody confused. Thank you for clarifying that. The friction forces are basically, to find the friction force, find the flat surface and do it parallel to the flat surface. Not, I was drawing normals. I'm sorry. I was thinking normals and the friction. Yeah. A lot of times students have trouble finding the normal force here to then find the friction force. So I'm glad you asked that. Friction forces, we should find the flat surface. Usually when you have, in all the problems we're going to have, there's going to be one surface that's flat, even if they're not both flat. Maybe there's a curve, maybe there's an edge. But find the flat surface, it's going to be parallel to the flat surface. That's right. And then this is the normal force, and my apologies. That's what I was thinking of, normal, not friction. I was saying one thing and meaning the other thing. So yeah, that's the normal force, and that's the friction force. So yeah, glad. Thank you for clarifying that. Hopefully people didn't miss that. Other questions? Fort Walton Beach, thanks for showing up. Any questions there? I'll crank you up. No questions here. It's okay. Ask some questions if you need to. One hint, I know of several problems at least, I think, a couple problems at least, I know, that it'd be useful to use either law of sines or law of cosines. Okay, so review that. Basically, there's a couple times where there might, and I think I even give as a hint once, there's times where you might need to figure out a distance to get an angle using law of sines or law of cosines. So it might be a good idea to review that so you know how to do it, just in case that pops up for you. That's a hint. That may not pop up for you, but it certainly could. I will also tell you as a hint that I don't see anything there with, I'm trying to remember. No, I don't see anything on the test of vector projections or anything like that. I didn't see anything there. I'm trying to make sure. I don't remember seeing anything with the dot product where you're going to need to find the angle between two vectors, like in 3D space. I don't remember any of that. Okay? These tests really follow the script. Okay? They really follow the script. And so that's the thing to remember, is that the tests are really going to follow that script right there. Okay? That's what they're going to do. Okay? So you really want to hone in on problems that are like this. In fact, you should be able to reference the book in these areas and find problems in the book fairly easily. Okay? If you want to look at Hibbler, 2D and 3D equilibrium is chapter 5. If you want to look at Hibbler, trusses and frames and machines is chapter 6. And I believe friction is chapter 8. And moment of inertia is chapter 10, I think. But you can find it. That's easy to find. So, frames and machines and trusses are both chapter 6, I'm pretty sure. So a lot of this test is 5 and 6. Hibbler, if you follow along in the book, a lot of this test is 5 and 6, because that's the hardest statics. Chapters 5 and 6. Okay? So if you do anything between now and the time you take the exam, study a lot of the problems in chapter 6. Remember, to do studying for statics, don't just read the book. That's a waste of time. Do problems. 5 and 6, chapters 5 and 6 would be really good. Friction's 8, moment of inertia I think is 10. So, yeah.
How long do we have to finish the final?
2.5 hours.
Can we expect multiple of each of these problems?
6 problems total. No, you expect one of each of these problems. So you have 6 problems in 150 minutes. So you have more than 20 minutes per problem. That's nice. You have, what, 25 minutes per problem? Okay? So that's a lot of time. Okay, there's plenty of time for this exam. I'm not trying to make it a time crunch. Plenty of time. Fort Walton Beach, any other questions? Please ask questions if you have them. Yeah, go ahead.
What do those numbers mean that are at the...
Oh, and at the end, that is the specific lectures. That I'm glad you pointed that out. Those numbers are the lectures in my notes. So each topic, those are the lecture topics in my notes that best correspond to that topic. Okay? So those are the ones I'd really hone in on studying. Going over those lectures, going over those. But the best thing to do is do problems that are similar. But yes, that's the lecture numbers. And make sure that you've got, if you've done the survey online, then I've got your test. I know where it's at. If you haven't, please make sure. This is for everybody who's listening to this later. If you haven't, please let me know, because I've got to get that. Other questions, Fort Walton Beach? Other questions, Pensacola?
So you said we have 2.5 hours to complete it?
2.5 hours, 150 minutes. That's the standard. That's the standard time. Yep. Make sure everyone, I'm assuming and hoping, has scheduled their exam. If you haven't scheduled your exam, then please do so immediately, because I know times are running out in certain times and places. And you have to take the exam no later than no later than August 8th. Okay, that's Thursday, August 8th. That's the last day, because I got to have some time to grade. So that'd be the 9th and the 10th and stuff. I got to turn in grades by Monday. So I don't have much time. Thursday, August 8th is the last day. Got to give me a little time to grade. Okay? If you have other questions, please reach out, email, whatever. I'll be answering email as best I can. Phone calls. If you want to come in, arrange a time to come in, we can still do that too. Okay? All right. Thanks all.
Yeah.